Hey, this is Mr. B, and today I'm going to be going over the study guide for your test this Friday. Your test on Friday is going to look very similar to this, so if this makes sense, you're in a good spot. Part 1 is going to be graphing quadratics. To graph quadratics, I'm going to have to find points that I can plot, and the easiest one to start with is the y-intercept. The y-intercept is simply this number at the end, or -3. So I'm going to put a dot at -3 on my y-axis, the one that goes up and down. To find the x-intercepts, this I have to factor. To factor this, I set it equal to 0, x squared plus 2x minus 3. And now I need two numbers that multiply to -3, but add to 2. So that's going to be x and x to start here. And what two numbers multiply to 3? Well, that's only going to be 3 and 1. Because the only numbers that multiply to 3 are 3 and 1. And then I know it has to be a positive 3 and a negative 1, because since it ends positive, the bigger one must be positive. These are the factors which are helpful, but I need to find the actual x-intercepts, so I set each of these equal to 0. And it becomes, when I solve these, I get x equals -3 and x equals 1. Set each of those factors equal to 0, solve for x equals -3, x equals 1. So I can put a dot at -3, and I can put a dot at 1. Cool. Now I have to find my axis of symmetry and my coordinate of the vertex. To find my coordinate of the vertex, I need to do -b over 2a. To do -b over 2a, I look here, my a is 1, because it comes from the number in front of the x squared, and my b is 2. It's the number in front of the x. So I plug it in, -2 over 2 times 1. That's just -2 over 2, which becomes -1. That's the x coordinate of the vertex I get from -b over 2a. However, I still have to find the y. To find the y, I'm going to take this x, I'm going to rewrite this equation, I'm going to plug in wherever I see an x, I plug in -1. So it's -1 squared plus 2 times -1 minus 3. Sorry about that. And this is my y. -1 squared, that's +1. 2 times -1, that's -2, minus 3. 1 minus 2, that's -1, minus 3, that is -4. Which means my coordinate of the vertex, my coordinate of the vertex is -1, -4. Cool. I now have enough to draw my graph. I just connect my dots, I don't forget my arrows, and that's my full graph. The last thing is my axis of symmetry. It's this line that I draw down the middle of the parabola that splits it directly in half. Since there's a vertical line, it's x equals, and it's always just going to be x equals whatever my x coordinate of the graph is. So in this case, it's x equals -1. I wrote that sloppy, but it's x equals -1. Because that's the line down the middle that I could almost like fold this over and it'd be symmetrical or the same on both sides. Cool. That's all of part 1. Part 2. Part 2 is solving these absolute value equations. The way these work, I have to first get the absolute value fully by itself, split them up, and solve it. So for this first one, which I'm going to zoom in a tiny bit so we can see better. This first one, I have to get this absolute value box by itself. So I'm going to add 6 to both sides. So I get rid of this -6 in the back. And it becomes 16 equals the absolute value of 2 plus 4. Again, I like to run my box around it so it looks nice to me. It's not by itself, there's just 2 in front of it. To get rid of this 2, I divide by 2, and I get 8 equals the absolute value of 2x plus 4. Once I get the absolute value by itself, I can now split it up to be two separate things, because this thing is 8. If I could somehow figure out when this thing without the absolute value is 8. If I can get this to be 8, I'm good. But since it's absolute value, I also have to figure out when it's equal to negative 8. Because if this thing in absolute value is negative 8, the absolute value will turn it positive, and that will also work. So I have to solve both of these equations to find which two answers are true. I solve these just the same, get my x by itself. Minus 4 minus 4, 4 equals 2x. Divide by 2, divide by 2, 2 equals x is one answer. Minus 4, negative 12 equals 2x. Divide by 2, negative 6 equals x. Those are my two answers here. Just a quick recap, I have to get my absolute value by itself. Get rid of the minus 6 next to it, and get rid of the 2 next to it. To get rid of the minus 6, I added 6. If I do it to one side, I do it to the other side. Then I divided both sides by 2, and I get 8 equals the absolute value of 2x plus 4. It could either be the positive or the negative version of 8, so I split it up to be two separate equations, solved each of them, and that's why both of these are my answers. Okay. For number 3, same exact game plan. I need to get my absolute value box by itself. There's a plus 2 next to it. I subtract 2 to get rid of it. Negative 22 minus 2, that's negative 24, equals negative 4 times 3x plus 3. My absolute value box is not by itself. There's a negative 4 in front being multiplied. To get rid of that, I'm going to divide by negative 4, divide by negative 4, and I get 6 equals the absolute value of 3x plus 3. My absolute value box is by itself, so I'm good. I can now split it up. 6, I'm going to do it up here so I have more space. 6 equals 3x plus 3, or negative 6 equals 3x plus 3. Because if this becomes a 6, I'm good, or if this becomes a negative 6, I'm good. To solve this for x, minus 3 equals 3x, divide 3, x equals 1. Minus 3, negative 9 equals 3x, divide 3, x equals negative 3. All I did there was just solve each of these for x by moving over the numbers. And these are my two answers there. Cool. Number 4, same exact game plan. Get my absolute value box by itself. There's a minus 8 next to it. To get rid of that minus 8, I add 8. Add 8. 16 equals negative 4 times the absolute value of 5x minus 2. I divide this by negative 4. Divide this by negative 4. Very important to divide by exactly what that number is. Since it's a negative 4 in front, I divide by negative 4. 16 divided by negative 4, that is negative 4 equals the absolute value of 5x minus 2. Hold on, if I do it 3 times, it'll be even enough. 5x minus 2. However, big problem. Absolute value always gives me a positive answer. Somehow this is telling me the absolute value is going to give me a negative. That can't work, which means there's no value for x that will give me a negative 4 when I take the absolute value of it. Therefore, this one has no solutions. Whenever you see absolute value at the end equal to a negative, it's no solutions. Number 3 looked like it was going to be no solutions because it started with this negative. But after I did all my math, moving over the negative 2 and dividing by negative 4, Two negatives actually made this a positive. Therefore, I was able to solve it. Cool. Part 3. Part 3 is just pretty much a matching column. You have to know what each of these parent functions look like really quickly. X squared, that looks like a u. The square root of x, that looks like a little mini wave. Let me draw it a little better. Some kind of mini wave. Absolute value of x, that is a v. Y equals x, that is a line. Y equals x cubed, I call that a spaghetti, but that's something that looks like that. Y equals a to the x, that is exponential. Those are the 6 parent functions that I need to know, and now it's just matching the pictures with which those look like. This first one is exponential, that's y equals a to the x. This one here is a line, so it's y equals x. This one here is a parabola, so it's y equals x squared. Looks like my u. This here is my spaghetti, y equals x cubed. Nothing crazy there, just memorize what those 6 functions look like, or be able to graph them in your calculator if you need a reference during the test. Part 4. This, in my opinion, is probably the hardest part. I'm going to do my best to make this make sense. We can write the same math equation in a few different ways, and it all is different ways of saying the exact same thing. Okay. We can write it in standard form, in factored form, or in vertex form, but I'm trying to say the same thing. It's kind of like how if I wanted to say I was 6 feet tall, I could say I'm 6 feet tall, or I could say I'm 12 times 6, which is 72 inches tall. I could say I'm 72 inches tall, or I could say I'm 6 feet tall. I'm saying the same thing in 2 different ways. Okay, same thing here. This is vertex form. And the way vertex form is y equals a x minus h squared plus k, which looks terrifying, but all it is a way where I can instantly know the vertex, and the vertex is my h and my k. So from this, I can instantly know my vertex coordinate because this number at the end is my k. So my k is -4. Okay. Now my h is the opposite of this number, which is very confusing. But it's supposed to be, right? It's supposed to be x minus h. This says x plus 5. Why is that a plus and that a minus? Well, if the vertex coordinate was just 5, right? It would be x minus 5 squared. But that's not what it is. So instead, it must have been x minus -5 squared, because that -5 makes it become a positive, which means the vertex coordinate is -5, -4. The best way that I like to remember that is that if it's in parentheses, in order to get it out, you take the opposite. We've kind of seen that before with factors. When we had the factors before of x plus 3, x minus 1, those x-intercepts became -3 and 1, the opposite versions of what was in my parentheses. It's the same thing here. The opposite version of +5, that's -5, and that's my vertex. Okay. Now, to go to standard form, right, I'm going to rewrite this as x plus 5 squared minus 4. To go to standard form, I have to expand this x plus 5. Well, x plus 5 is really x plus 5, x plus 5 minus 4. All I did was write x plus 5 twice. Now, I'm going to double distribute this or box method, whichever way you like, it does not matter. and I get that because x times x is x squared, x times 5 is 5x, 5 times x is 5x, 5 times 5 is 25, and I don't forget the minus 4. Lastly, I combine these two like terms, and I combine these two like terms, and I get y equals x squared plus 10x plus 21. That's it in standard form. I may have done that a bit fast. Do it one more time. I expanded my x plus 5 squared. I rewrote it twice. I double distributed it and got this. Combined my two 5s and got 10. I don't forget about the minus 4 at the end. Younger Mr. Bateman would forget about that. You're going to be better than Mr. Bateman. You're not going to forget about it. That minus 4 and that 25 combined to be plus 21. That's it in standard form. To factor it, I'm going to rewrite it again. X squared plus 10x plus 21. I need to think of two numbers that multiply to 21, but add to 10. Multiply to 21, add to 10. I list my factors of 21. That's either 1 and 21 or 7 and 3. I see that 7 and 3 get me 10, so it's plus 3 and plus 7. These three, x plus 2, x plus 7, x squared plus 10x plus 21, and this one here, are all three ways of saying the exact same thing, which kind of sounds silly, but each one of them has their separate benefits depending on what you're asking for. This is kind of the basic one. You kind of do most things from this. This is a factored form. We factor for the x-intercepts. So I instantly know the x-intercepts are -3 and -7 if you give it to me in factored form here. I don't know what the x-intercepts are here. I don't know what the x-intercepts are here. But here I do. So in this form, it makes sense to me. And that's why this way is the best for the x-intercepts. But what if I don't want the x-intercepts? I just want the vertex. This one's best for the vertex. So each one kind of has their slight benefit. Okay. Number 2, I'm going to go from factored form into standard form. Standard form. My vertex coordinate and my vertex form. Okay. To go from factored to standard, I'm going to box method or double distribute. I double distributed before, so I'll box method here. Whichever one works for you does not matter at all. X times x is x squared. -4 times x is -4x. X times 2 is 2x. -4 times 2 is -8. These two terms here can combine, and I'm left with y equals x squared minus 4x plus 2x minus 8. As I said, these two combine, y equals x squared minus 2x minus 8. That is my standard form. But now I need my vertex. To find my vertex from here, let me do this so I have more space. Maybe I won't. Nice, this won't work. Okay, never mind. Ignore me. Sorry. Just ignore this because this is a different question. To find my vertex, I'm going to do -b over 2a. This is to find my vertex. Every time, -b over 2a. Unless they give it to me in vertex form, then I just know it instantly. -b over 2a. My b is -2, and my a is 1. So it's -2 over 2 times 1. -2 is silly. That's just 2. 2 over 2 equals 1, which means the x-coordinate is 1. But I still need to find the y-coordinate. To find the y-coordinate, I'm going to replace x squared minus 2x minus 8. I'm going to replace wherever I see an x, I'm going to put 1. And this becomes 1 minus 2 minus 8. 1 minus 2 is -1. -1 minus 8, that's -9. So my vertex is 1, -9. I didn't do that with the most space. Let me say it, just make sure you understand it. I did negative b over 2a to find my x. Once I had my x, I plugged it in wherever I saw an x. 1 squared was 1, negative 2 times 1 was negative 2. 1 minus 2, that's negative 1. Minus 8, that's negative 9. To put this into vertex form, y equals a x minus 8 squared plus k. Don't worry, you will have that formula on the test. However, you need to know how to use it. This is my h, this is my k. So I can plug it in. Y equals, my a is 1 from before. 1. X minus 1 is my h. Squared plus negative 9 or just minus 9. And this, and this, and this are all three ways to say the exact same thing. Cool. Keep it going. This here is my vertex coordinate. From my vertex coordinate, I can instantly go to my vertex form. Y equals a x minus 8 squared plus k. Y equals 1 x minus negative 6 squared plus negative 4. Because this is my h, that's my k. Take my h, plug it in. Take my k, plug it in. Y equals, I don't need this 1 in front because technically this 1 is multiplying, so I don't want to put it. Double negative, that's just x plus 6. Squared plus minus, that sounds confusing, minus 4 at the end. This is my vertex form. I just took this h, plugged it in, took this k, and plugged it in into my equation. Now, I'm going to take this x plus 6. That's actually x plus 6 twice, right? And now I can double distribute or box this. I boxed the last one, so I'll double distribute. X squared plus 6, x plus 6, x plus 36. Because x times x is x squared, x times 6 is 6x, 6 times x is 6x, 6 times 6 is 36. And I don't forget about the minus 4. I combine like terms, x squared plus 12x, those two can combine to become 12. 36 minus 4, that's plus 32. Y equals x squared plus 12x plus 32. That's it in standard form. Now I want it in factored form. I have to think what two numbers multiply to 32, add to 12. Well, what multiplies to 32? I know 1, 32, 2, 16, 4, and 8, and I think that's it. So I look which one gets me 12. No, no, yes. Y equals x plus 4, x plus 8. These three things are three ways to say the exact same thing. Cool. I got one more. Then we're on to part 5. This is my vertex coordinate. This is standard. This is factor. Okay. From here, I have my vertex equation. I can instantly find my vertex coordinate. This is my y equals x, or a, x minus 8 squared plus k. H is 2, and notice how it's negative, so I flip it to positive. This is negative 1, and it stays negative 1 because it's not in the parentheses. That's my vertex coordinate. To get this to standard form, I have x minus 2 squared, that's x minus 2, x minus 2, minus the 1. X minus 2 twice, I have to box method that out, or I can double distribute, does not matter. X times x, that's x squared. X times negative 2, that's negative 2x. X times negative 2, that's negative 2x. Negative 2 times negative 2, positive 4. X squared. These two, negative 2 and negative 2, they're going to combine for me in a second. I'm going to combine those to be negative 4x. And this plus 4 minus 1, I'll combine that to be plus 3. So my standard form is y equals x squared minus 4x plus 3. Standard form. Now I get my factored form. I need to find what multiplies to 3 adds to negative 4. And I know that my only options are 3 and 1, because that's the only factors of 3. And they both have to be negative in order to add to a negative 4. I also know that if they're both negative, they multiply to a positive. Factored form, standard form, Vertex form. Cool, almost done. Part 5 is function transformations. This, you just have to memorize that table in your notes. I'm going to really quickly go through it one more time. If I had to make the table by myself right now, here's what I would need to know. Number at end, up or down. The number at the end is either makes it go up or makes it go down, depending on if it's positive or if it's negative. That's rule 1. Number in parentheses is left or right. If it's in parentheses, then it's minus, that's right. Parentheses, then it's plus, that's left. We'll get there in a second. Just know, number 1, number at the end, up or down. Number in the parentheses is left or right. 3, number in front of x squared is the compress. This is actually terrible handwriting. Compress or stretch. Okay, number in front is either compress or stretch. And the way that works is if it's bigger than 1, it compresses. If it's like less than 1, it stretches. Technically, you're gonna ignore the negative. Just deal with positive is a positive version. Bigger than 1, compress. Less than 1, stretch. And lastly, negative sign equals flip. These are my 4 rules I kind of have to know. Okay, so my first one here, and of course I did it right in the way, but I'm gonna do my best. This plus 4 at the end. Number at the end means up or down. It's positive, so it's up 4. Nice. Number in front. Number in front, that's compress or stretch. Is it bigger than 1? It is, so it compresses. This plus, that's all I gotta do for letter A, for the first one. Plus 2 at the end, that's up 2. X minus 4, that's right 4. If I had to predict the way most students get this wrong, it's gonna mix up with the deal with the parentheses. The parentheses are very tricky, but I had to think of it as the opposite. The same way we saw on the vertex coordinates, you take the opposite, is the same way here. Instead of x minus 4, think of that as positive 4, because it's the opposite, and that's why it's right 4. If that doesn't make any sense, you can also just memorize the rules. X minus 3, that's right. X plus 3, that's left. Plus means left, minus means right, if it's in parentheses. Okay. That's all this letter B. Letter C, I see a negative sign, so I know it has to flip. I see a minus 1 at the end, so I know it's down 1. And I see a 0.3. Is 0.3 greater than 1? No, it's not. So it's going to stretch. Stretch. Down 1, flip, stretch. Lastly, down 2. X plus 1, that's left 1. Because it's plus 1, I think negative 1, left 1. Okay, cool. That's also kind of like part 3, where it's mostly just memorizing these rules. Lastly, this is where it looks the scariest, but it's not. We have f of x and we have g of x here. Hold on. I know that f of x is just a y. But the main reason to call it f of x is because if I somehow had like multiple lines going on, having multiple y's is confusing. So instead of having multiple y's, I call one of them f of x and one of them g of x. It's just different names for similar equations. Okay. So this is telling me f of x is this thing. There's some kind of equation going on here. I know it's an x squared, and I know it's up 6. So it's something like that. That's my first one, f of x. I don't have to draw it, but it might help. G of x is some other function. It's something else on my graph. And it's the same thing as f of x. If I take f of x and deal with this x plus 3 in parentheses nonsense. Well, I just learned that x plus 3 in parentheses, that means shifted left 3. So how is g of x shifted? It is shifted left 3 because in my parentheses means left 3. So somehow g of x is going to look something like this, shifted left 3. I know that because of the rules from before. Now I need what the actual equation though is, because just knowing where it is might be helpful, but I also might want to know the equation to find out what the equation actually is. The reason why it's called f of x is because it's like plugging in this x into wherever I see an x, which is why if I asked for before f of 2, that would mean plug in 2 in place of x. So in this situation, I'm just making this up just to prove a point. Give me 2 seconds. F of 2 means 2 is replacing the x. So that's why this would become 2 squared plus 6. 2 squared, that's 4, plus 6. F of 2 equals 10. All I did, the 2 replaced the x. Okay? If it said f of 4, I would do the same thing. 4 replaces the x. So it would be 4 squared plus 6. 4 squared is 16 plus 6. That would be 22. Okay. The reason why I'm showing you that is because now it's f of this thing. It's no longer just a 2 or a 4. It's this thing. But the rule stays the same. Plug this thing in wherever I see an x. So my equation for f of x is x squared plus 6. To find g of x, I'm going to plug in x plus 3 wherever I see an x, right? So I rewrote x as x plus 3. Now all I have to do is expand this, which is very similar to expanding the vertex equation. This I can rewrite twice. I can either box or double distribute. I'm going to double distribute. X squared plus 3x plus 3x plus 9 plus 6. I don't forget about the plus 6. It comes straight down. X times x, x squared. X times 3, 3x. 3 times x, 3x. 3 times 3, 9. Now I just combine like terms. X squared doesn't have any like terms, so it stays x squared. 3x and 3x combine to be 6x. 9 and 6 combine to be 15. And this is an equal sign. This is the equation for this blue parabola over here. I was able to find it by plugging x plus 3 wherever I saw an x into there. Math is getting hard, I know. But I'm hoping that made sense. How it's shifted, that's just looking at the rules. What the equation actually is, I plug in. Okay. Lastly, because I'm getting tired of math myself, f of x is this thing, okay? G of x is the same thing as f of x, but it's somehow shifted with this -4 in parentheses. This -4 in parentheses, I remember my rules from before, that makes it go right 4. Okay, so I have f of x. Let me do this in black and that one in blue, so I'm consistent. This is blue. G will be blue. So I have some kind of, to be honest with you, I don't know much about this parabola. So I'm kind of just going to freeball. I know it's a parabola. Intercept is 4. Probably looks something like this. Now this one is the same thing, except shifted right 4. So maybe it's something like that. I don't know for sure. I could do more method if I wanted to. But I'm just digging for a loose sketch. I just know it's moved to the right 4. Now I gotta find what the actual equation is. To find the actual equation, I take this x minus 4 and I plug it in to the x. So my original equation, f of x equals x squared minus 2x plus 4. But now my g of x is wherever I see an x, I put x minus 4. Wherever I saw an x, I replaced it with this blue, x minus 4. Cool. This is my equation for g of x. Just getting there is most of the work. Now it's just simplifying this whole line. Well, this here is x minus 4 twice, so I can box method that. X minus 4, x minus 4. And that becomes x squared minus 4x minus 4x plus 16. So I can rewrite it as x squared minus 4x minus 4x plus 16. This, I box method, and I got that. This, I have to distribute this, because it's a number in front of the parentheses. So this -2 times x, that's -2x. -2 times -4, that's plus 8. And actually this plus 4 didn't have any x, so I didn't touch it, but it still comes down. I have this big row of craziness, but I'm just gonna look to combine like terms. I'm gonna rewrite my final answer over here once I have it. G of x equals, I know it's gonna be x squared, because x squared, there's no like term with it. I'm now gonna do the x's. Let me do it underline in blue. -4x, -4x, -2. -4, -4, -2, that becomes -10x. -10x. Because -4 minus 4, it's -8. -2, it's -10. Lastly, I have these numbers. Plus 16, plus 8, plus 4. 16 plus 8, that's 24. Plus 4, that's plus, 28. And this is my equation. This is the same as that, just shifted to the right 4. I hope that makes sense. If you have any questions, hopefully you're not watching this night before, hopefully you're watching this Wednesday night. If you could ask me in class tomorrow. I hope this helped. Good luck studying.